Hey guys, Mr. Backberg here. In this video, we're going to look at applications of the law of cosines. So as we're taking a look at this first example, we're going to look at finding a measurement on a baseball diamond. Now, a baseball diamond is a square with side lengths of 90 feet. So this distance from home plate over to first base, that's a distance of 90 feet. Now, the pitching rubber is 60 feet 6 inches away from the back edge of home plate. So that's going to be 60.5 feet. And I want to find the distance from the middle of the pitching rubber over to the back corner of first base. So I'm going to call that my x value in here. Now, because we're dealing with a square, all of these angles in the corners are 90 degrees. And when I draw this straight line running down the middle of my diamond, that splits that 90-degree angle in half. So this actually ends up being a 45-degree angle. Now I'm going to label the angles of this triangle so we can use our law of cosines to help us out. So at home plate, I'm going to call this A. At the pitcher's mound, I'm going to call this B. And at first base, I'm going to call this C. So based on what we've got, we're trying to find side A and we're using angle A. So I'm going to use the law of cosines form that has angle A in it. So that's going to be A squared equals B squared plus C squared minus 2BC cosine of angle A. So we don't know what A is. That's going to be our x, and we're going to square that. B, the side across from angle B, is 90, and we'll need to square that. Plus the side that's across from angle C is going to be that 60.5, and we'll need to square that. Minus 2 times 90 times 60.5 times the cosine of angle A, which we said was 45 degrees. Now, if I type that right-hand side into my calculator, we should get about 4,059.86. But I don't want x squared, I just want x. So I'm going to have to square root both sides. So then that x ends up being a distance of about 63.72 feet. So just a little bit short of 64 feet from the middle of the pitching rubber over to the back corner of first base. So in this example, we're going to look at a regular tetrahedron. And a regular tetrahedron is a solid that's got four faces, and all of those faces are equilateral triangles. And what we're going to be doing is finding the measure of what's called a dihedral angle, and that's formed along the common edge of two intersecting faces. Now, in our regular tetrahedron, we're going to say that the edges have a length of 2, and because all of these triangles in here are equilateral, then every single edge length in our picture is actually going to be 2. Now, to form our dihedral angle, what we're actually going to look at is finding the midpoint of one of our segments. And I'm going to look at this DE segment right here. And I'm going to put a point along the middle of that segment, and I'm going to call that point B. Now, what I'm going to do with that is I'm going to connect that point B up to angle C, and I'm going to connect that point B over to angle A. And that's where we get our dihedral angle. That's the angle measure that we're trying to find. Now, what's actually going to happen in here, because the faces of our shape are all equilateral triangles, then each one of these individual angles, like angle E over here on this face, is a 60-degree angle. Now, when I draw in that line connecting point B to point C, it actually splits that 60-degree angle in half up top and forms a 90-degree angle down here. So it actually ends up creating a 30, 60, 90 triangle in here. So this length from B to E is 1. This hypotenuse length is 2, meaning that this side connecting B and C would have to be the square root of 3. And actually the same thing is going to be true for the side connecting A and B. That's also going to be a length of the square root of 3. Now this AC, because it's one of the edges of our tetrahedron, we said that this was a regular tetrahedron, meaning that all of these edges had a length of 2. So we're actually looking at this ABC triangle in here with this length of 2 and these lengths of square root of 3. We're trying to find the measure of angle B, so I'm going to use the form for the law of cosines that has the measure of angle B in it. So that's going to be B squared equals A squared plus C squared minus 2AC times the cosine of angle B. And we're trying to solve for B, so I'm going to take this A squared and C squared and subtract them over to the other side. So this will say B squared minus A squared minus C squared equals negative 2AC times the cosine of angle B. And then I'm going to divide that negative 2AC over to the other side. So we're going to have B squared minus A squared minus C squared divided by negative 2 times A times C equals the cosine of angle B. Now, based on what we have in our picture, side B is 2, and that needs to be squared, minus side A is the square root of 3, but that needs to be squared, minus side C is also the square root of 3, but that needs to be squared. And then we're dividing by negative 2 times root 3 times root 3, and that equals the cosine of angle B. So on top, 2 squared is 4. When we square each one of these root 3's, they just turn into 3. So 4 minus 3 is 1. Minus 3 is negative 2. And on bottom, we've got negative 2. Root 3 times root 3 is just 3. And this equals the cosine of B. So we've really got negative 2 over negative 6 equals the cosine of B. But this is going to reduce down to 1/3. So we've got 1/3 equals the cosine of angle B. And in order to get B alone, I'm going to do the inverse cosine. So angle B is the inverse cosine of 1/3. And if I type that into my calculator, then angle B ends up being about 70.53 degrees. That's going to be it for this video. Thanks for watching.